Moving on with more questions since our meeting is over. Number 26 in 9.3. So these are getting into review questions. So they are concepts you do know, but they're not specific to 9.3. This one's actually for 9.2. If you look at the review next to each question, it tells you which lesson it came from. So for 26, you're given this function. You have to do the domain and range. So domain and range. Domain is all your x's that you can put into this equation, and range are all the y's that you could possibly get out. So is there any number, let's think about positives, 0, and then think about negatives. Is there any positive number that I could not take to the 5th power and the 7th root? No. Are there any, because 0 to the 5th power and 7th root, that's fine, it's just 0. Can I take a negative number to the 5th power? Okay, that's a negative number. Can I take the 7th root of a negative number? Yes. You can't take an even root of a negative number, like the square root of -3. Can't do that because that's imaginary. But if I take the 3rd root of it, that is possible because I can have an odd number of a number multiplying by itself 3 times to get to -3. So this does allow me to put in negatives, 0, and positives. Thus, the domain is all reals. When I do that, I'm also going to get out all reals. If you graph it, did I have it already in my graph? I did. Okay, graph. If you graph it, it looks like that. It works on every single number. It'll go forever in both directions, okay? To do the inverse, I'm going to switch the x and the y where they're at. To undo the 5th, 7th degree, exponent, then I'm going to do the 7/5, multiply that, so take 5/7 exponent to the 7/5 exponent. Those multiply to make 1, so I'm left with just y, turns into f inverse of x, and then x to the 7/5 becomes the argument for the equation. So that is my inverse, and this is what that window specifically looks like on part C. And then 31 was another review question people asked for. There we go. Well, it's going to fall back down again. But 31. So we have a $5,000 5-year investment at 5.5% quarterly interest. So it happens 4 times a year. This is our formula. The amount accumulated equals the principal times 1 whole, because you're increasing, plus the rate that it's increasing at, how many times it's compounded, how many times it's compounded for how many years. So 5,000 principal, 100%, 5.5%, 4 times a year, 5 years, and your investment will grow to $6,570.33 because it's money. You do 2 decimal places. All right, and that ends the specific questions. General questions. ln means natural log. That's a log with a base of e. Okay? So log base e of 1 would equal 0, because any base doesn't actually matter. If the argument's of 1, you know your answer is 0, because anything to the power of 0 is 1. Other common log applications like the Richter scale, the main idea is that a log replaces a geometric series, like 1/1000th, 100th, 1/10th, 1, 10, 100, 1,000, so the rate here is 10. It replaces this geometric series with an arithmetic one, because this is the power, 10 to the power of -3, -2, -1, 0. So if I have a log base 10, I can change the power of 10 to log base 10, and now it's geometric to arithmetic, and it's a lot simpler to work with because it's just differences and not a different ratio. So in this case, log base 10 of n is 10 to the nth power. I found a website that just talked about this. So the common log of 58 gives you this. That means 10 to the 1.7634 equals 58 digits. So whatever number this is 58 digits. Another cool thing was log base of 10, because you don't see it. So this is base 10, this is base 10. So log base 10 of log base 10 of x is 1, which means that this 10 to the 1 is 10. So that means this inside log of x, log base 10 of x, equals 10. which then means 10 to the 10th equals x. Drawing arrows is awesome. I know it may seem silly, but it helps so much. Okay. Find values of exponential functions without calculators. If I give you big numbers, yes, I know in the quiz was a kind of big number, that hopefully you'd seen that before. So they should be small enough numbers or numbers you've seen before that you can figure this out. So this is a cube root. You're looking for 3 numbers that multiply by themselves, it's all the same number, to make 125. You know they're all positive because they have to all multiply to make a positive 125. So you can start with the basics. 1 times 1 times 1, 1. 2 times 2 times 2, 8. 3 times 3 times 3, 27. You're going to get larger really fast. So I already went from 8 to 27. From 27, then you get 4 cubed. That's 64. 5 cubed. Oh, that's 125. So that would be 5. Yes, it would take some time, but the goal is that they're small enough numbers or you're more familiar enough with them, it'd be okay. So the one that we had on the quiz was 256. Yeah, I'll go ahead and do it. So for 256, it wanted 0.5. That's the same thing as saying the 1/2. That's the same thing as saying the square root. So I need 2 numbers that multiply by themselves, the same number, to make 256. Hopefully you know all the way up to 144. So 12 squared is 144. It's awesome if you know 13, because that's 169. 14 is 196. So then you don't know 15 and you don't know 16, but you know it has to be greater than 15. 20 squared is 400, so you know it's less than 400, so it has to be less than 20. And yes, you could do guess and check. But now you're down to either 15, 16, 17, 18, or 19. You're down to 5 numbers to try, and 16 is your answer. Another thing to look at is, if I'm doing 15 squared, what's 5 times 5? 25. You're going to end up with a 5 in the ones place. Is 5 in the ones place? No. 15 can't be your answer. 16. What's 6 times 6? 36. You're going to end up with a 6 in the ones place. Do I have a 6 in the ones place? Yeah. Okay, that's worth me checking out to see, is this right or is this wrong? Okay, 6 and 6, 36. That's a 9, 0, 6, 1, and that would be 6, 15, 256. So, yes, it takes some guess and check, but knowing your squares will help you so much. It makes your life a lot faster in your brain. So, I think that was all the questions, at least the majority of them. If you have any others, come to office hours or post them in the attendance, and I will read them.